Students, today we will learn the chapter Limits, Continuity and Differentiability. Students, as in the previous video, I have already explained about the limits. In this part, I will recapitulations of some limits formulas, revision, refreshing. Then after that I will tell you in the next part continuity, then differentiability. So you have go through the previous video so that you can learn the words limit. In this part I am giving you some formula explanations only. So for refreshing you know the following formula, and you should know the following formula. Limit of x tends towards a, x to the power n minus a to the power n upon x minus a equal to n a n minus 1. Student, you want to go through this formula in the previous video also, how you have derived this formula. Okay, I am going to revision only. Now the second formula, limit theta tends towards 0, limit of sine theta is 0, and also if we take the limit theta tends towards 0 of cos theta, that is equal to 1, and sine theta upon theta, theta tends towards 0, that is equal to 1. This all formula you have already proved in the previous video, just you have to remember this. So tan theta upon theta, theta tends towards 0 is also 1, and some more formula, sine theta minus a upon theta minus a. If theta tends towards a, that is equal to also 1. Theta tends towards a means theta minus a. Take this here, theta minus a tends towards 0. Theta minus a tends towards 0. Okay, means theta tends towards a. Similarly, tan theta minus a upon theta minus a, theta tends towards a, you can write directly, it is 1. No need to prove it. And theta tends towards 0, and we can take the mod of sine theta upon theta. Then this limit does not exist. Why it does not exist? It will be described in the next part. So you have to wait for this. Okay. Now sine theta minus a mod upon theta minus a, limit taken theta tends towards a, it is also does not exist. Similarly, for mod of tan theta upon theta, theta tends towards 0, that is also does not exist. And mod of tan theta minus a upon theta minus a limit theta tends towards a, it is also does not exist. Student, to proving this formula, sometimes following expansions are helpful in evaluating the limits. So you have to learn the following expansions. Okay, so you have to learn these expansions, and from where these expansions are coming. One is binomial theorem. If you want to be learn in detail, you go to the chapters binomial theorem. Okay, in detail you should know this theorem in detail so that you can easily used anywhere. This one is the binomial theorem for any index where x less than 1. Okay, now logarithmic series at e base. If you want to know the detail of logarithmic series, you should be go to the chapters logarithmic series. Okay, if you're putting here minus x, so put here minus x square minus x cube, all the terms are in negative, so we can find next one for minus x, that is minus x square by 2 minus x cube by 3 minus x by 4 minus x to the power 5 by 5 minus dash dash dash. And you should know the exponential series. For detail you should go the chapters exponential x square upon factorial to 1 plus x upon factorial 1 plus square upon factorial 2 plus x cube upon factorial 3 plus x to the power 4 upon factorial 4 and so on. And you put here x is minus x e to the power minus x, so you can find out the series, that is e to the power minus x. Putting minus x, you can find the series 1 minus x plus x square upon, you can write here factorial 1 factorial 2 minus x cube upon factorial 3. For odd power it will be negative, x to the power 4 upon factorial 4 minus x to the power 5 upon factorial 5 plus dash 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 up to infinite. And similarly in exponential you can find the value of ax. For detail you should be go to the exponential chapters. For the same, e to the power x 1 plus x log ea upon factorial 1 plus x log ea whole square upon factorial 2 plus x log ea whole cube upon factorial 3 plus dash dash dash. And next formula is sin x is x upon factorial 1 minus x cube upon factorial 3 plus x to the power 5 upon factorial 5 minus x to the power 7 upon factorial 7 plus dash dash dash. And series of cos x that is 1 minus x square upon factorial 2 plus x to the power 4 upon factorial 4 minus x to the power 6 upon factorial 6 plus x to the power 8 upon factorial 8 minus dash dash dash, and 10x exponential of 10x x plus x cube upon 3 plus 2 upon 15 x to the power 5 plus dash dash dash. Student, these three sin x, cos x and tan x, we will find the using formula Binomial Theorem and exponential of ex. Comparing this, we can write eix equal to cos x plus I sin x. If we compare this series cos x and sin x, putting the I here, and you know what is the I, that is the root minus 1 in polar form. In complex number, you know about this, okay? I square equal to minus 1, I cube equal to minus I to the power 4 equal to 1, and so on. Using this and comparing both sides, we can find the series of cos x and sin x, and using Binomial Theorem we can find the value of tan x also. Okay, student. Now first go to the more formula. I want to describe you here some evaluations of limit of inverse trigonometric functions. Okay, so inverse trigonometry function, you should be learn this formula. Limit of x tends towards 0 sin inverse x upon x, that is equal to 1. Now we are going to prove it. Let sin inverse x equal to theta, then we know x equal to sin theta. If x tends towards 0, then theta tends towards 0. Then sin theta is 0. Okay, so we can write this LHS theta upon sin theta tends towards 0. Now we can write it theta tends towards 0, 1 upon sin theta upon theta, and we know this limit is 1, so we can write is 1. It is the proof of this. Okay, now similarly for we using tan inverse x upon x tends towards 0 is 1. So similarly tan inverse x equal to theta, then x equal to tan theta. If x tends towards 0, then we can say theta tends towards 0. Hence our LHS question is theta upon tan theta tends towards 0. We can write here 1 upon tan theta upon theta tends towards 0. 1 upon 1 is equal to 1. So this formula also you have to learn. Student, involving inverse trigonometric functions, we convert the limit in terms of trigonometric functions by replacing the inverse trigonometric functions. Okay, then we can solve the inverse questions easily, as you have seen the formula. Now I want to also revise some exponential limits. A to the power x minus 1 upon x tends towards 0. that is equal to log e base a. How you can prove this? Using the series of x to the power a to the power x. What is the series of a to the power x? We can write here 1 plus x log ea upon factorial 1 plus x log ea upon factorial 2 whole square plus dash dash dash, and it is minus 1, and dividing by it by x, x tends towards 0. We can see this one is cancel out, and taking the common here, x log ea, we can write here x log ea upon factorial 2 plus x log ea whole square upon factorial 3 plus dash 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 upon x. Here x tends towards 0, cancel out x, add this factor is cancel here, so now it is defined function. So now putting the value of x0 here, so all these terms are 0 except this one. Okay, so now we can say 1 plus 0 plus 0 plus 0 0 equal to 1. And what about the common is here log ea, that is left here, so here we can write log ea into 1, it is equal to log ea. Okay, student. Here is log ea left, so we can say here is log ea into 1. So answer is log ea. Similarly, we can use this formula also, log e base 1 plus x upon x, x tends towards 0 is equal to 1. So how we will prove it? Using this series here, x minus x square upon 2 plus x cube upon 3 minus x to the power 4 upon 4 dash 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 upon x, x tends towards 0, using the series of log 1 plus x. Okay, now taking the common x and dividing by this x, what we get here, 1 minus x upon 2 plus x square upon 3 minus dash 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 upon x, x tends towards 0, this is cancel out. Now putting this x, we get 1 minus 0 plus 0, higher power of x is 0, so that is equal to 1. So since a to the power x minus 1 upon x, x tends towards 0 is equal to log e base a. Let a equal to e, then we can write here e to the power x minus 1 upon x, x tends towards 0 equal to log e base e, that is equal to 1. So we can say this series upon x, x tends towards 0 is equal to 1. And also we can already prove the series using the series of ex, we can find also it is equal to 1. Okay, so using this or exponential formula and logarithmic formula of inverse, we can solve so many questions. Now we will like to be solve some questions on this to understand this formula and some typical questions. Okay, first we will solve some easy questions, then we will solve some tough questions. So now question is, For practice, I am doing some questions so that you can understand use of these formulas. Okay, now question is limit x tends toward 0 1 upon x sine inverse 2x upon 1 plus x square. In all the trigonometric part, you should know how to simplify this questions in the trigonometric form. So you should be understand the chapters inverse circular functions. If you don't know the inverse circular functions chapters, then you go to that chapter first, then solve this one. What is the meaning of sine inverse 2x upon 1 plus square? How we will solve it? Okay, so here I am going to explain it. Since we know sine 2 theta equal to 2 tan theta upon 1 plus tan square theta, this is the identities using as a formula. We can use it if we write here 2 theta equal to tan inverse sine inverse 2 tan theta upon 1 plus tan square theta. Now if tan theta equal to x, then theta equal to tan inverse x. So putting here 2 tan inverse x equal to sine inverse 2x upon 1 plus x square. Now using this formula, we can evaluate this question easily. If you learn this formula directly, you can put here directly. Okay, so we can write here 2 tan inverse x, and this one is also x. Now use the formula as above, tan inverse x upon x, theta tends towards 0, that is equal to 1. So we can write 2 this one, and this formula is 1. So this is your answer. Okay, so if you know the inverse circular functions, then you can go to easily way. Now try to do next question. Limit x tends towards 1 that it is LHL limit minus 1. So question is, it is exist only LHL. Okay, so it is given LHL only. Cos inverse x whole square. One minus root x upon cos inverse x whole square, using here LHL limit only, since it is exist only LHL limit. Okay, so whenever we find the root, then we should use the conjugate. Okay, so you can solve so many questions if you're using the conjugate. So we multiplied by 1 plus root x upon dividing by 1 plus root x. Now when we put x equal to 1 here, so 1 plus 1 2, it is not 0, but we put here 1, then it is 0. So removing the 0 factors, numerator and denominator, we use the conjugate whenever you find the root. Okay, this method you should be learned. So using a minus b, a plus b, we use this formula a square minus b square, and in denominator we are cos inverse x whole square 1 plus root x, x tends towards 1 minus. So next term is, we can check here, one minus x upon cos inverse x whole square 1 plus root x, x tends towards 1 minus. Now it is inverse function, so let cos inverse x equal to theta, then x equal to cos theta. So x equal to 1, then theta tends towards 0. X tends towards 1, then theta tends towards 0. Okay, so student, here we are not taking the minus 1. Minus is shown the Lecture limit only. Now putting this here, we can say 1 minus, now x equal to cos theta upon theta square 1 plus root cos theta. Okay, theta tends towards 0. Now using the trigonometric formula, we can change in sine form. So we can write here 2 sine square theta by 2 upon also theta square. If we multiply it by 2 and square, so we have multiplied here dividing by 4, so we should be right here 4, and here theta tends towards 0. And here also next term is 1 plus root cos theta, theta tends towards 0. Now we can solve this. It is 1 square, it is cancelled out 2, so 1 square it is 1 by 2, and putting here 1 plus cos 0, that is also 1. Now we got the limit 1 plus root 1, that is 1 by 2, 1 upon 2, it is equal to 1 by 4. So this way you can describe some questions on the limit part of inverse functions. Okay, so using the inverse circular functions, you have to simplify all the inverse questions, then you can solve in easy way. If you try it, you can do it better. So student, I am going to be some more question on exponential form. So now the question is limit x tends towards 0, a to the power x minus b to the power x upon x, x tends towards 0. How you can solve it? So we know the formula a to the power x minus 1, so subtracting here minus 1 and also subtracting here minus 1, minus into minus plus 1, and it is minus 1, so left is a to the power x minus b to the power x, this term is equal, and dividing by x, taking the x LCM we can find it. Now putting the limit here separately. Now you know the formula of this one, isn't it? What is the formula of this one? That is log e base a minus log e base, here is b, so we write here formula b. Now using the logarithmic formula, division formula, log e base a upon b, so this is your required answer. Okay, so we will do next question. To the power x minus 1 upon under root 1 plus x minus 1, x tends towards 0. So student, we can say here a to the power x minus 1 and it is conjugate root. So this is another question, this is another question. So we can write here this one x. If we dividing by this x separately, this one is the separate formula. Now this one, okay, and by multiplying this so that this should be equal, and conjugate of this 1 plus x plus 1, and we can find here root 1 plus x whole square minus 1 square. Okay, so this way you can separate these two type of the questions. Now what we left here, this is 1, but what we left here, so 1 and x, here is under root 1 plus x plus 1 upon here is root 1 plus square is 1 plus x minus 1, x tends toward 0. Now this one is cancelled and this x is cancelled, so what we left here, under root 1 plus x plus 1, x tends towards 0. Okay, and also we have getting here to the power x not 1, it is log e base 2. Log e base 2. Okay, the formula of this log e base a is 2, log e base 2. So into log e base 2. Now putting this here, value we can find 1 root plus 0 plus 1 into log e base 2, that is equal to 1 plus 1, 2 root 1 is 1, 2 log e base 2. Okay, so this is your required answer. I think you are going to be understand how we are using the formula in the given questions. You have to judge your questions. The questions is which formula is contained, and we have to separate that formulas, and then we can solve it easily way. Student, I am going to tell you some tough questions using the rationalizing of the numerators and denominators. Okay, now question is x cube minus 7x square plus 15x minus 9 divided by x to the power 4 minus 5x cube plus 27x minus 27, x tends towards 3. Now student, if you put here directly 3, what you got it? When you putting the x equal to 3 here and also here, on putting x equal to 3, we will find this indeterminate form. I mean, this is the equal to 0 and this is also equal to 0. It means x minus 3 is a factor of numerator also and denominator also. Okay, so we can say hence x minus 3 is a factor. So dividing by x minus 3 to this and x minus 2 this, we can find the question separately, and you can divide yourself. Okay, so when you can divide this, so we will get the question this way. One is the factor x minus 3 of numerator, other is x square minus 4x plus 3, and dividing by denominator x minus 3, we will get x minus 3 x cube minus 2x square minus 6x plus 9. This is your homework, you can divide yourself. Okay, so this factor is cancelled out now. Now is it this part is again putting the value of x equal to 3, it is also, we can see, it is again divisible by 3. It is also again putting again, put x equal to 3, we again find 0.0. So again dividing by x minus 3 and dividing by x minus 3, we get again this formula, x minus 3 x minus 1 upon x minus 3 x square plus x minus 3. Putting x tends towards 3, again we cut it. Okay, now if we put directly 3, now it is not undefined, so we can put it here directly, 3 minus 1 upon 3 square plus 3 minus 3, so that we can find the answer 2 upon 9. Okay, so this way you can divide this content, and using remainder theorem you can find, or division method, you can find this quotient. Since it is a divisor, so your remainder is 0, you find this quotation and quotient. Okay, so this type of the question you have to use this way. Now I am doing some tough questions more for you. Limit x tends towards 0. Question is x plus 1 square plus x plus 1 cube plus dash 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 plus x plus 1 to the power n minus n plus 1 upon x. Student, you have to check each term very carefully, then you can understand which formula we have to use it. Student, you can see here the formula is x to the power m minus a to the power m upon x minus a. Okay, if we check this formula, x to the power n minus a to the power n upon x minus a, x tends towards a is n a to the power n minus 1. So if you want to check this carefully, so x to the power n, you can see this bracket power n, this bracket power n, and minus a to the power n, you can take this one x here minus 1. X plus 1, and from here n can be written as 1 plus 1 plus 1 n times. Okay, so this one n times, you can adjust this n here also. So we can write here this way, x plus 1 minus 1 plus x plus 1 square minus 1 square plus x plus 1 cube minus 1 cube dash 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 x plus 1 to the power n minus 1 to the power n. So this plus 1 going with this. Okay, and this n is written here 1 1 1 and this one. Understand? Where is n? N is written as 1 plus 1 plus 1 n times. So n comes to 1 here, n comes to 1 here, n comes to 1 here, 1 here, n times. And this one is coming from here. Okay, upon x. Now let x plus 1 equal to y, then x equal to y minus 1. If x tends towards 0, y tends towards 1. Okay, so we can write here y minus 1 upon this x can be written as y minus 1. So dividing by y minus 1, y tends towards 1 plus y square minus 1 upon this x, like it and try y minus 1, y tends towards 1, y cube minus 1 cube upon y minus 1, y tends towards 1, plus dash 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 dash, and the last is y to the power n minus 1 to the power n upon y minus 1, y tends towards 1. So now using this formula, okay, what is the value of here? This is a cancel out, but here is n a to the power n minus 1. N is here square, here is cube. Okay, so we can write the answer is very carefully 1 plus 2 1 to the power 2 minus 1 plus 3 1 to the power 3 minus 1 plus 4 1 to the power 4 minus 1 at the last n 1 to the power n minus 1. So we can write here 1 plus 2 plus 3 plus 4 plus n, that is equal to sigma n, and you know the formula for sigma n plus 1 upon 2. This is your required answer. So student, I have solved here some tough question and some easy questions for your revisions. Okay, in the next part I will tell you about the continuity, and then I will tell you differentiability, okay, and what is the differentiation I will explain you. So you have to wait for some. So thank you for watching.